Okay, today we're going to see this example that you see on the screen with the following objectives. We're going to draw a bond graph model of it. Then we want to write the equations of the system. And then we want to get ready those equations to generate a block diagram that you can actually use in Simulink. So let's follow the steps that we have for modeling systems of electrical nature, electrical circuits, step by step, and then generate the bond graph first, then write the equations, and then we'll do the block diagram. So I'm going to disappear from here. All right. So let's just go on the first steps to do this bond graph model. Let me just pick up the red coloring here. What I would like to do is I put the distinct currents for each loop. So this would be I sub 2, and then I would do it for this, which would be I sub 3. So with this, the first step that we have to generate the bond graph model is to put a one junction for every distinct current loop. Yeah. So that's the first step. Perhaps we could write it down in here if it's helpful. The first step is use a one junction for each distinct current. Okay, so we did that. Then the next time, the next step for us is attach all elements that experience those currents. So let's do that. You see here there is this element which is the source of effort in there, and so we will put the source of effort in here like that and attach to this like that. Then you have the R element, which you have this, and then over here we see the difference in currents. This also see this is attached to one between this is I sub 2 and this is I sub 3. You have this TF element, so that's TF like that. And then you have in here you'll have R with value R sub 2, and you have this here. This is the I element with value L, and you have the C element with value C sub 2. Okay. In here you see you have a capacitor that sees the difference between these two, but in this second step we attach the elements that see the distinct currents. So what's our next step? Step number 3 would be to represent the difference in currents with zero junctions. Represent the current differences with zero junctions. and then attach the elements that experience those differences. Okay, very good. So what are we saying here? We go over here and say this is a 0 here, and that is going to have this current minus this current is going to be I sub 1 minus I sub 2. Don't forget that this is I1, and that's, we have done this step, and now we attach the elements that see those differences. And that's this element in here. I1 minus I2 is seen by this C element, which has obviously has the value C sub 1. Okay. So once we have this bond graph model, we assign the causal marks. So I am going to change colors here again. First, we assign it to the source. CAMG will do this for you, but I believe it's better to also know how to do it by hand. But the Ising integral form, that makes this element like this. And because of that, this like that. Then in here, of course, this could be simplified, but we'll have to go like this. And now we need to put the Ising integral form over here like this, which makes this take this, and then since only one input to the 0, the other one will have to be like this, and therefore this one has to be this way. We put the numbers onto the bond graph model. 3 and 4 and 5 and 6 and 7 and 8, and I'm not simplifying anything. We're just gonna leave it like this, and we'll use it like this. Very good. So we have done the first objective, which was to come up with a bond graph model. Then we're going to write the constitutive equations of the elements. And the one way is to write down the number, and each one of them, I'll just say, for example, this one will have E1. Let me just change maybe to another color here. So let's say E1 is equal to SE1. F sub 1 is equal to F sub 2. E sub 2, we are following the causal marks, is E1 minus E sub 3. F sub 2 is 1 over R times E sub 2. Okay. And then you have F sub 2, E sub 3 is going to be equal to E sub 4 because of the 0 junction. And F sub 3 is F sub 2. And then you have E sub 4 is equal to E sub 5. And F sub 4 is equal to F sub 5. That's why this could be simplified here and here. Two simplifications we could make. What about D sub 5 is equal to 1 over C sub 5 Q sub 5. Then you have F sub 5 is equal to F sub 4. And the first differential equation coming out of the C element is going to be that this is going to be dq dt. dq, what is 5? dt is equal to what? F sub 5. And this, if you substitute this, no, there's no substitution at this point. Erase this thing here. Okay, so this is F sub 5. And then you have E sub 6. E sub 6 is E sub 6 is E sub 4. F sub 6 is equal to F7. E sub 7 is equal to E sub 7 is equal to E sub 6. And F sub 7 is going to be also equal to F sub 6. Yes or no? No, F7 is F8 times TF.
So in the sense that you kind of rehash
See,
how you're satisfied
yeah, we are writing the individual equations like here. E sub 7 is E sub 6, but F7 is F8 times TF. 7, 8. E sub 8 E sub 10 minus E11 minus E sub E sub 8 is E7 times TF. That is wrong here. E sub 8 is E sub 7 times TF 7, 8. And so we continue on what's F sub 8. F sub 8 is equal to F sub 10. And E sub 8 E sub 8 is E7 times TF 7, 8. And now where's E9? E sub 9. This is what is this? E sub 9 is F9 times R9. sub 9 times r sub 9, and then I'll just go here, f sub 9 is equal to f sub 10, and e sub 10 is 9 minus e sub 4. Yeah. E sub 10 is e sub 8. This is an 8. Okay. What's f sub 10? Is 1 over I sub 10 p sub 10. That dp10 dt is going to be equal to e sub 10. And then you have E11. E11 is 1 over C times Q11. And then we have F11 is equal to F sub 10. So okay, so that's what we have so far. How many differential equations in here? We have one because of the C element, one because of this C element, and one because of this. So we are missing one. At the end, this one, dq11 dt is equal to f11. Now, my point is that once you have these equations, you could simplify them and write them in a more compact form. Like, for example, you could say, you could substitute many things in there and come up with one set of equations that can be used for simulation. Well, this can be used for simulation, it's fine. But you could simplify them a little, like dq5 dt is equal to f sub 5. If this, look where f5 is. This is equal to f sub 4. And what's f sub 4? F sub 4 is now here you have a problem. F4 is f3 minus f sub 6. Okay, so this is f sub 3 minus f sub 6. And you keep substituting. What f sub 3 is f2. And what is f sub 6 is f sub 7. So this would be equal to f2, which is, yeah, f2 is 1 over r2 times e sub 2 minus f sub 7 is f8 times tf8. And so we still need to keep substituting this. E sub 2 is E1 minus E sub 3. And this times 1 over R sub 2. And then we have F sub 8 times, where is F sub 8? It's F10. F sub 8 is F10. Times TF 7, 8. F sub 8. So this is going to be minus right here too. And so we continue. This is AC1 minus E sub 3, which is E sub 4. And E sub 4 is E sub 5. Times 1 over R sub 2 minus F10 is 1 over I10 times TF 7, 8. Okay. I think we are, no, we're not done yet because that E5 is still is minus E sub 5 is, what is it? 1 over C sub 5, Q sub 5, but multiplied by 1 over R2. Okay, so that's this minus so this is minus 1 over I10 P sub 10 times TF so this is the first equation. And we need the other one. The other ones are gonna be much easier. dP sub 10 dt is equal to E sub 10, and E10 is E5 minus E sub 4 minus E sub 9. And then E5 is equal to what? 1 over C5 Q sub 5. E4 is told you 1 over same thing. E sub 5 is 1 over C sub 5. Sorry, we need to go to question is E4 is the same. E4 is E sub 5. I hope I didn't make a mistake in here because it looks a little funny here. One dP10 is E sub 10, and this is, yeah, see here I have a little bit of a problem here. This I copied it wrong. This is E sub 8 minus E sub 4 and minus E sub 9. So I 11, I don't think we have done it yet. Let me see. I think we need to erase something here. This E sub 8 is the one that we need to get back. Here's E sub 8 is E sub 7 is E sub 7 times TF 7, 8. And then minus E sub 4, which is E sub 5 minus E sub 9 whereas E sub 9 is E8 minus E10 minus E11, right? No, E sub 9 is F9 times F9. Yeah, we are still, so E sub 7 is E6 and E6 is E4 and is E5, 1 over C sub 5 Q sub 5. Q sub 5 times TF 7, 8 minus E5, which is 1 over C sub 5 Q sub 5 minus F sub 9, which is the same thing as F10 times R9. Okay, let's finish writing the dp sub 10 dt. I'm just doing substitutions, right? 1 over C sub 5 Q sub 5 TF 7, 8 minus 1 over C sub 5 Q sub 5 minus F10. F10 is 1 over I sub 10 P sub 10 and then times R9. Let's just do it right. I think we need to erase it here so it looks pretty. So this is F10 is minus 1 over I10 P10 and then times what? Times R9, right? That's what this is. So we done the second one, and the last one is the Q11 dt is equal to F11, and F11 is F10. This is 1 over I sub 10 P sub 10. Once you have the equations in this form, in this one, see if I can make a little frame here. Once you have it, then you can actually use them. Let me see, this one right here. I need to circle this one. This is dq sub 5 dt. And you have the other equation that you have this for the second one. You have it in this form, and this one like this. Once you have those, you can use them for plotting. And the last one is this. So you have those three equations. So the question is, can you use the block diagram? Can you do the block diagram from this? That's where we are. So let's just do that. So you have three summation points. So because you're gonna have three equations. The first one is dq 5 dt. This one, I'm just gonna put the terms in here. This right here is dq sub 5 dt like this. Here, there. And then I have an SE over R sub 2, which is a term like this. SE over R sub 2. And then you have this minus C sub 5 Q sub 5 minus 1 over C sub 5 R sub 2. Yeah, that's that term. And then you have one more, which is, this one is minus 1 over I sub 10 P sub 10 times TF78. Really? Yeah. So that's this equation. I would do the other summation points a little farther down, and then we'll see how we are going to add them up. See, so that the second one is visible. Oh yeah, I have it visible here. It's close in red, right there. So I would do this. Where's my cursor now? See right here. So I would do the second one in here. This one is your dp10 dt. Yeah. And it has this term in here that says TF78 divided by C sub 5 times Q sub 5, right? Yeah, and then it has only one more term in here, which is minus 1 over C sub 5 Q sub 5. Yeah, excuse me, there's one more here. This one is minus P sub 10 over I sub 10 times R sub 4 sub 9. Yeah. And they finally have this last one. That's the third equation. I think this one is easy. We could put it. I'm just gonna put it right here. This one is an easy one. This is dq11 dt. Yeah, and then this, it has only one input, which is 1 over I sub 10 p sub 10. Once you have transformed those three equations in summation points, now it's time to do the integration like this on each one of them. 1 over s, and what you get is q sub 5. And then you, of course, could put it in this one. You do 1 over s, and then you obtain p sub 10. And then, of course, you could do the same thing on a scope. Do it here, 1 over s. What you have done is calculated all the state variables, because those are the ones needed for the other factors. See, this one has which one was this? 2 times R2, but it didn't. Q sub 5. All right. All right, here. See this one? It's Q sub 5. But because the Q sub 5 is over here, you would go here, do the multiplication of this, do 1 over C sub 5 times R sub 2, and then you connect it right there. See? This one for P sub 10, fine, you pick it up from here, come here, do the multiplication. Here is 1 over I sub 10, and then TF78, and then you connect it over here. And that's the end of that. This one has Q sub 5. As you can see, you need Q sub 5 here. Multiply it by 1 over C sub 5. And there it goes. And this other one is P sub 10, which you pick it up from here. Go and here, this would be 1 over I sub 10 times R sub 9. And then finally you have to do the connections here for P sub 10, which you will connect like this, 1 over I sub 10, and then there you have the system of equations. I mean, system block diagrams of those from these equations. What you have in here is these equations in here. These are the individual constitutive equations that you see. These are the ones that you see in here, this one. From those, I just simplify them by substituting into these three. These three are called the Cauchy form equations. And from those equations, I did a block diagram. So that way we have completed the example.